Consul and Vault are both GA on HashiCorp Cloud Platform, and that is what we're going to investigate today. Now, you may have noticed that I didn't mention Terraform in any of that, and that's because we're going to be using Terraform and Terraform Cloud to deploy Consul and Vault on HashiCorp Cloud Platform. So if you want to know more about that, tune in. This is going to be a good Terraform Tuesday. What's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to Terraform Tuesday. We are going to be terraforming it up. Hopefully, you've got your tacos all ready to go. Today's topic is all about deploying HashiCorp Cloud Platform Consul and Vault using Terraform and Terraform Cloud. Now, I'm throwing a lot of jargon in there, so I'm going to cover what those are in a moment. Before I dig into that, just a quick reminder, if you want to support this show and get these episodes a week early, as well as my weekly newsletter, you can do that on Patreon. So that's how you can do that. So check out the link. It's down in the description. If that's not your thing, hey, quick reminder, I also do a daily podcast, or at least during the week, it's a daily podcast called The Daily Check-In, and it's like about 10 minutes of just my thoughts. So I'm not taking up an hour. I'm not taking up 30 minutes. This is 10 minutes. You know, if you're walking the dog or doing some random task, you can listen to it and get some interesting tech advice, some career advice, or just general thoughts on what's going on with me. So if that's of interest to you, that link is also down in the show notes. So definitely check it out. Give it a listen. Let me know what you think. I want to hear it. Anyway, let's talk about what's going on in the world of HashiCorp Cloud Platform. Okay, so what is that? HCP, what is that? Let's start with that thing, and then we'll work into the other topics, right? So HCP is basically a managed version of the software that HashiCorp provides. Now, the two obvious candidates for that are Vault and Consul, because those are two things that you need to set up a cluster of servers to run. It's not like Terraform. You're not setting up a cluster of servers to run Terraform. I mean, generally, you're not. And even with Nomad, you might not necessarily be setting up a cluster of servers to run Nomad, but Vault, well, you need to set up one or more Vault servers to, offer the Vault service. Same thing with Consul. So the idea here is, what if instead of setting all that stuff up for yourself, what if you could just get it as a service? Click a button, boom, you've got Vault, or boom, you've got Consul, and then you can make that service available to all of your applications that you want to integrate. Good idea. That's what HashiCorp Cloud Platform is, and right now it is only available on AWS. Now, how do you connect to this thing? Good question. The way that you do it is when you go create an instance of HCP, you create an instance of a HashiCorp virtual network. Now, the implementation detail here is that on AWS, it's basically a VPC. And then they spin up the resources inside that VPC, and they manage things like upgrading the version of Vault that's running. They provision the whole environment for you, and you get some options when it comes to sizing. How big do you want your Vault or Consul environment? Do you want to use a development instance or a standard instance? And that comes with some caveats as well. But the nice thing is that, at least on the Vault side, and I assume this is true of Consul as well, you're getting the enterprise version of the software. So those enterprise bells and whistles you might not have with the open source version, well, you get them. So that's a nice kicker. So you have this HVN, HashiCorp Virtual Network. That's where your Vault and Consul service resides. And then you peer that VPC with other VPCs in your environment, or you can wire it into the transit gateway. So you have a couple options for getting things to connect. You have control over the CIDR block that's used inside that HVN, so you can make sure to pick a CIDR block that doesn't conflict with any of the other services you might be offering. And I have it on good authority that the smallest block you can choose is a /25. So you could choose a /24, and that gives you a pretty good range of different address spaces you could plumb, and I'm sure you could find a /24 that you have available in your IPAM software for this service. So hopefully that works for you. If you're in other clouds, if you're in Azure or GCP and you want to consume this thing, you can also enable a public endpoint for either Vault or Consul and make it publicly accessible. Now, the downside to that is there's no firewall controls at the moment, so you can't say make it publicly accessible, but only from these source public IP addresses. If you make it publicly accessible, it's publicly accessible. That's just the way it is right now. There may be a future enhancement where you can control some of those firewall rules. I gotta imagine, at least on the AWS side, that would be really easy. You would simply just enable network ACLs and security groups for that VPC that the HVN exists inside of, and you'd be good to go. There's also, and this is a little confusing, there's a separate Azure offering to do Consul as a service on Azure that you can get directly through the Azure Marketplace. That is also managed by HashiCorp, but you pay for it through Azure, whereas HCP, you pay for it directly to HashiCorp. It's not part of the Amazon Marketplace or anything like that. So just some points of distinction there. It's only available in AWS right now, but it will be coming to the other clouds as they build out the service. So just bear that in mind. So how are we going to deploy this thing? How are we going to dig into it? Well, there are some prerequisites that you have to have in place, and let me go over those briefly. All right, those prerequisites that you have to have in place if you wanted to follow along with the demo I'm going to be doing in a few minutes. Well, first of all, you need a HashiCorp Cloud Platform account. You can sign up for one, no problem. There'll be a link down in the description on where you go to sign up for that. It's free to sign up. You can use your GitHub account. It's very easy. So no big deal there. The second thing is you're going to need an AWS account. Obviously, since we're deploying this thing in AWS, you need an AWS account so you can provision a VPC and like an EC2 instance to interact with this thing. If you don't want to do that, you could manually provision a Vault or Consul instance, make it publicly accessible, and then you don't need AWS stuff at all. But for my demo, I am deploying stuff in AWS, so you need that account. You also need a key pair for EC2 instances in the AWS region that you plan to deploy in. I'm using US East 1, and I already have a key pair. If you don't have that, you're going to need a key pair. And lastly, because this thing is going to use Terraform Cloud for remote state and execution, you're going to need a Terraform Cloud account, which those are also free. And when you create an organization in Terraform Cloud, you get up to 5 free users, including yourself, and you can sign up for it with GitHub. So most of this is free, basically, is what I'm saying. So let's actually go over to the interfaces for HCP and Terraform Cloud and see what those things look like. Okay, starting with HCP, this is the HCP portal that I have logged into. Right now, I don't have anything provisioned, so it just takes me to the overview, and I can see I can get started with Consul or Vault. When you sign up, at least right now, as of when I'm recording this, you get a $50 credit, which is plenty if you're only going to be spinning up the development instances. I don't remember the exact pricing, but it's something like 3 cents an hour for the development instance of Vault and 2 or 3 cents an hour for Consul. So you could run both of those for an entire month, and I think the $50 would still cover it. And that's assuming you run them for the whole month. So that $50 credit is going to go a decent ways. Down on the left, you can see there's the HashiCorp virtual network. So that's an HVN. You can have one or more HVNs provisioned. And then below that, you have the resources of Consul and Vault. And then lastly, under Terraform, that will take you to Terraform Cloud, where you can provision all this stuff. Before we get into that, the last thing I want to call out is under Identity and Access Control. It has the access control right here. And under there is service principals. Now, in order to do this whole thing, you're going to need to create a service principal here. That is the credentials that Terraform Cloud is going to use to talk to this via the provider and provision the HVN and the Consul and Vault instances. So you're going to need to create this service principal ahead of time and then copy down the client ID and client secret that it gives you when you create a service principal. All right, so that's HCP. We got that covered. On my other tab, I've got the HashiCorp Terraform Cloud login going, and I am in a workspace that I have helpfully named Terraform Tuesday HCP. And within this, I set it up to run from the CLI because you can have Terraform Cloud point at a CLI remote execution, or you could have it point at some sort of version source control for when it kicks off a new run. I'm just doing it from the CLI. I did have to add some variables in here. So if we go under variables, here are the variables that I have outlined. I've got the key name, which I have set to HCP because that's the name of the keys that I created in US East 1 for AWS. I also have the client ID and client secret. Again, those are the credentials that Terraform is going to use to talk to the HCP provider. And then below that, I've got my AWS variables as environment variables, and that's the access key and secret key for the region and user that I want to use to create resources on AWS. So that's the two portals. Those are the settings that you're going to have to configure in the portals before you go ahead and run through the demo. Now, I've already done all of this, so we can go over to Visual Studio Code and start walking through the configuration. Now, just as a brief explanation before we dive into the configuration, I have broken things out into modules as much as I can because I have a feeling I'm going to reuse some of this stuff. So I did want to get it into modules. So I have roughly 4 modules that are being used, and they're all controlled through a main.tf, a main root module. So we're going to dive into what those are. I don't know what level of detail I should really get into. As usual, all this stuff is available on GitHub in my Terraform Tuesday repository, so I don't need to go into every nuance and detail. You can pick it apart if you want, but let's go over to Visual Studio Code and get an idea of what's going on there. Okay, here we are in Visual Studio Code, and the directory that these files are in is 2021-04-27. That's when I'm publishing this particular video for my patrons, and then you'll get it a week later. So if you're watching it a week later, that's why the date is what it is. And within there, like I said, I've got 4 modules. One is the HCP network. So that's to create the HVN, or the HashiCorp virtual network. The next one is the HVN AWS peering. And like I said, we are going to peer this HVN with one of our VPCs in AWS. So that module handles the peering of the VPC with the HVN. And then I've got a module to create the Vault instance and another one to create the Consul instance. So that's the overall structure here. And then I'm also going to be creating a VPC dynamically for the peering. So I'm going to be using the VPC module that's available on the public registry. So with that in mind, there's also a really good README here. So if you want to run through the README, it kind of breaks things down a little bit on what prerequisites you're going to need to follow along and all that jazz. Let's open up the main.tf and just kind of see what's going on in here. Okay, so like I said, we're going to create a VPC. And I actually set this up that you could create multiple VPCs because you might want to pair multiple or peer multiple VPCs and consume these services. So I have it using a count. And it's looking at a variable called VPCs, which is a custom object that I'm creating within the variable. And we could jump over to that in a moment, but let's just look at the structure of the whole thing before we dive into the details. So we'll start by creating that one or more VPCs using the VPC module from the public Terraform registry. Then we are going to create the HVN, the HashiCorp virtual network. And for that, the only inputs that you really need are the region you want to create this in. So that's going to be US East 1, the CIDR block you want to use to create this HVN. And remember, you don't want this to conflict with any VPCs you want to peer with this HVN. And then finally, a naming prefix. What do you want to name this HVN so you know what it is? And it's basically going to take that prefix value and then add a dash and then a random string of characters so that it's unique within your deployment. So you could do this a number of times. Below that, we create the peering connection between any VPCs that have been created via that previous module that was further up and the HVN that we created. So it's going to create one peering connection for each. And as part of that peering connection, it's also going to set up the routing from the VPCs to the HVN. So on the HVN side, you have no insight into that VPC. You have to tell it what the CIDR blocks are for the VPC you're peering, and it adds it into the route table for the HVN. You have to go add those to the route table on the VPCs to say any traffic bound for the CIDR block that the HVN is using, send it down the peering connection. And so that is handled by this peering module, adding those routing connections. We also have to add the VPC ID. the HVN CIDR block, and the HVN ID. So we need all of that information for this peering module. Once we have the peering relationship set up, we will create an instance of Vault. And for that, all we need is the HVN ID. Where is this Vault instance being created? Do we want it to have a public endpoint? And that's set to false by default, but you can update that variable to be true and it will give you a public endpoint. And then finally, a naming prefix. It will use the same naming prefix you're using for everything else for consistency. Consul is basically the same. You need that HVN ID, you need to set whether or not you want a public endpoint, and you need a naming prefix. Once you have all that created, you actually want to access Consul and Vault, and the way that we do that is by spinning up an EC2 instance on one of the public subnets, and then making it accessible via SSH so we can connect into it and test out our connectivity with our new Vault and Consul instances. So the way that we'll do that is we'll get the latest version of Amazon Linux, and then we will create a security group that allows SSH from anywhere. And I know best practice is not to allow SSH from anywhere. So please, if you're using this for production, don't do this. You can borrow some of this stuff in the modules, but don't do this. You want to lock production down a little bit more than that. And then I'm going to create an EC2 instance. And as part of that EC2 instance, I am going to add some user data in here that it will run as a script as the EC2 instance comes up. So maybe it makes sense to take a look at what's in that template file. So here's the template file that it runs when it starts up. What we're going to do is first install all the HashiCorp tools using yum. Once we've done that, we're going to install Vault, Consul, and then make sure JQ and curl are installed because those are common tools you're going to use to interact with Vault or with Consul. Then we're going to bootstrap our Consul and Vault connections. So as part of the outputs from the modules, it generates an admin Vault token for us to use. I'm going to write that token out to Vault token, the file, so that we have a token we can use to connect to Vault with. And then I'm going to write out the private Vault address to a file as well. We're also going to generate an admin token for Consul. And so I'm going to write that out to Consul token. Now we have ways to connect to all these various things. Now we're also going to run the Consul agent on this EC2 instance. So we need to create basically some files that we'll use to configure the Consul agent and get it up and running. And those are going to go into the directory /opt/Consul. So we'll make that directory. The things we need to run the Consul agent, we need the certificate authority for the Consul servers or server that's running in the HVN. And we can get that from the outputs of when we create the Consul instance. So we have that. We're going to write that out to a file called ca.pem. And then we can also get the client config from the outputs of creating a Consul instance. So we'll write that out to client config.json. And then we have to replace one value in there, changing the path for the CA cert to where it's actually going to be. So just a quick command to do that. And then lastly, how is the agent going to authenticate? We need to give it a token, a Consul token to talk to the Consul server. And so we'll write that out to client acl.json, and we'll add in the Consul token there. And then move all of those files from the home directory into /opt/Consul, and we are all set. So all that's going to happen when the EC2 instance comes up. And then once we SSH into that EC2 instance, we'll be able to run some test commands to verify that Vault is working and that the Consul agent runs successfully. Okay, so that's the whole setup. Why don't we go through the actual deployment? Okay, so let me go ahead and bring up the terminal here. And as always, we'll go ahead and run Terraform init first. I should also mention that I'm using Terraform 0.15. You definitely want to be on 0.15 or newer when you do this. Otherwise, I'm not certain that everything that I've done inside of these modules is going to work properly. The other thing that I want to point out is that the HashiCorp HCP provider is 0.5 right now, so it's still relatively new. They're still adding some functionality to it. So I was a little constrained on what I could put into these modules because the provider itself is still being developed to a certain degree. Now that I've done this, I have it set up using a remote backend, so it probably makes sense to look at that now. Under the terraform.tf file in my root module, we can see the backend is set as remote. I have the organization in there and the workspace it should be using. And I ran Terraform login to get myself connected with credentials to Terraform Cloud to do these remote runs. Okay, so that's another thing that you have to do ahead of time. Since we've initialized successfully and we're all ready with our remote backend, we can go ahead and run Terraform plan. And what's interesting about this, if you've never used the Terraform Cloud Platform before, it actually runs this remotely. So it's sending these instructions to Terraform Cloud, and then it's going to mirror the output back to the CLI here. So you can see it's using Linux AMD 64. That's all happening on some remote container or runner or worker in Terraform Cloud. And then it's just mirroring the output back to me on what would happen if it ran this apply after it did the plan. So this is purely just a plan. It's not actually applying anything right now. Let's go ahead and wait for it to finish. And there we go. Sometimes it pauses at the end before it actually gives you the CLI control back, but we can see that it's going to add 21 new resources. So our plan completed successfully. We know it's actually going to deploy some resources. So now the next thing that we can do is we'll do apply, and we'll just add an auto approve on there so we don't have to wait. And we'll go ahead and kick that off. Now, if we go over to the Terraform Cloud console, we can see this remote plan and apply happening in real time. It actually gives us a link to do that. If I open it, there we go. It's loading now. So this is the remote plan that we just kicked off. If you do an apply, it's going to run a plan first. That's the way it works. And when it's done the plan, if you use the -auto approve switch, it will automatically jump to apply. So the plan is currently running, and then it's going to get into the apply. And this mirrors essentially what we would see in our CLI as well. So you can really monitor it from either. If this had been done through version control instead, we would only see what's happening through the console as opposed to at the CLI, because the change would have been kicked off by some sort of commit or merge on the version control side. All right, so this is now running the apply. The thing you need to know about spinning up these various services is spinning up the Vault and Consul services can take up to 10 minutes. And I don't think you want to watch me stare at a screen for the next 10 minutes. So through the magic of editing, we'll fast forward to that time. But before we do that, I think it makes sense to just jump back to the HCP console. And if we go to the virtual network, we can see there's now a virtual network there. So it has provisioned that virtual network. If we go to Vault, we can see it is in the process of creating our Vault cluster. And if we go to Consul, it is in the process of initializing this cluster. For whatever reason, it takes you right into that cluster view, but that cluster is also initializing. So those are spinning up. Like I said, you don't want to wait the 10 minutes. So we'll fast forward this to the point where this has successfully applied. All right, our apply finished. If we hit the drop down here, it gives us some outputs, but we don't really need those with the exception of the EC2 public DNS. If we had created multiple EC2 instances, there would be a whole list here, which is dependent on how many VPCs you created. Since we only created one VPC, we've got one public IP address to connect to our EC2 instance from. So let's go back to Visual Studio Code and actually make the connection from there. All right, we're back in Visual Studio Code, and you can see that the remote run from Terraform Cloud still gave me the output locally, so I can go ahead and use that information. So we're going to go ahead and do an SSH, and the name of the user is EC2 user. So we'll go ahead and put that in. And now we need to copy that public IP address. Go ahead and paste that in here. And then we're going to need to refer to the key pair that I used. So I'll go ahead and put that in as well when I called that HCP. There we go. And yes, I would like to connect. There we go. We're connected. And if everything ran successfully, if we do an ls, there's our console token, our vault address, and our vault token. If we cat out, say, the vault address, there we go. That's the private address to get to that instance of the Vault cluster that's running. So important to know that this uses the development instance of both Consul and Vault by default, because I want it to be as cheap as possible, which also means there's only one actual server behind each one. So don't use this in production because it's called development for a reason. Anyway, so what do we do now that we're here? Well, if we look in the README and scroll down to the bottom, I have a few commands that you can run to try out some stuff. And we can start by exporting the Vault address and Vault token values into environment variables so that we can then check on the status of our Vault server. So I'll go ahead and copy those, paste them down here. There we go. And now if we do Vault status, it's going to reach out and say, hey, looks good. Let me actually move that up a little bit so you can see all the information. You can see that it's initialized, it's unsealed, and that we are connected, and it's version 1.7 enterprise. So you have all the enterprise features available to you here. By default, it creates a namespace called admin, I believe, but you can create additional namespaces. So if you've ever wanted to play with Vault namespaces, here's your opportunity. Now for Consul, we can run the Consul agent. And remember, the configuration is in the directory opt/consul, and that is also what we're going to use for the data directory. So we'll go ahead and run sudo consul agent and point it at the configuration and also use the same data directory. And we'll just put the little ampersand there so it runs in the background. I'll go ahead and run that first. There we go. All right, so this will join up to the existing Consul cluster as an agent. You can see adding server and synced node info. So we're good. It has successfully connected to the Consul cluster. If we want to see the members of our Consul cluster, we can run this command consul members, and we have to give it a token to authenticate that command with, and we can pull that from the Consul token file. So I'll go ahead and highlight that now, and we'll go ahead and run that command. And we can see we have two members. We've got one that is the server, and it's running build 195 enterprise. So again, you get access to all the enterprise features in Consul. And then we have our local Consul agent that we just started up, all part of this Consul deployment. So that's pretty much it. That is how you can use Terraform to deploy HCP Vault and HCP Consul and get it peered to an AWS VPC. Now, as you saw in the demonstration, I created VPCs as part of the demo, but you probably already have some VPCs. So you can take the modules that I've already created as part of this and reuse those modules for your own existing VPCs if you don't want to create one on the fly. And this allows you to not only play around with HCP, but also play around with the enterprise features of Vault and Consul. Something that I've been wanting to do, and especially getting a copy of those enterprise licenses, is pretty pricey. Now it's just available. You can just play with them. That's kind of awesome. So that's going to do it for me today. Thank you so much for watching. As always, I really appreciate everyone subscribing and liking the videos and giving me all the great feedback. The comments are fantastic. And just so you know, I do read all the comments. And even if it takes me a little while, I try to respond to them as well. So keep the feedback coming, keep the requests coming. I make this every week and I've got a long list of things to do. But if you have a great suggestion, please put it in the comments. I will try to get to it as I do these different Terraform Tuesdays. Until next time, stay healthy, stay safe out there, and bye for now. Hey, want to know a secret? When I do recordings for Pluralsight, I have this. This is a clicker. Every time I screw up when I'm trying to say something, I click, and then I try to say it again, and every time I click, I can see it in the audio waveform, and that tells me that I messed something up and that I should delete where I see the click and keep the take that happened after the click. So, little fun fact for you there. Bye.